name's Jeff Sadler, and I'm on a team with Cuyler Frisbee, and this is our Advanced GIS project. Our project objective was to make a map atlas of all of the watersheds in the state of Utah. So the shapefile that we used to loop through was this one in green here. These are watersheds delineated by the state of Utah called HUCs, and we made a map of each of the HUCs and delineated watersheds within those, and also added a stream network. So this is an example of one, and you can see the green outline is the HUC and the stream network, and then the thinner lines within the HUC are subwatersheds that were delineated using mapping tools in ArcMap. So that was our objective, is to make an atlas of each of these zoomed into the right extent. And I'll go ahead and show you our final product. So here it is. The main view has the HUC in red, then the delineated watersheds with these thinner lines, and the stream network is the blue lines. You can see the location of this in regards to the state of Utah down here in the inset map. And this was done. I don't know what that is. So this was done for each of the main watersheds in the state of Utah. Now I'm going to show you how our tool works. If you scroll to it in the toolbox, select it, there's this user interface which allows you to input the main watershed's shapefile and the DEM, which is used to delineate the watersheds and create the stream networks, a stream threshold, which determines the density of the streams used in the analysis, and then a location where you want to save your PDF, your the end product PDF, the atlas. So I'm just going to load in the ones that we used, and that might take a second. And we'll leave the stream threshold at 50. That seemed to work okay. And we'll go back and save it where we've been saving it. And we're going to start running that tool. So one thing we added, which was nice, is to have the user updated by the program on the progress. So it says beginning geoprocessing for the first HUC, and that will continue through all of the HUCs. We used the method of making individual HUCs, or excuse me, individual PDFs, and then appended them all to the main one. And I can show you the intermediate ones, which are being saved in this folder. You can see that this was made about a minute ago, or this minute. And if you open it, it's the individual Colorado Plateaus watershed. Now we were going to add a base map, and we originally did that, but the program stalled a little bit while we were running through our code and wouldn't run through each of the HUCs, so we decided to take that out and do without. So I'll turn it over to Cuyler, who will take us under the hood and show us what's happening in the actual code.
Hi, this is Cuyler Frisbee, and like Jeff said, I'm going to take you through our code and show you how it works on a little more detailed level. So here's the script that our tool is based on. Go ahead and open this up and show you how it works. So our first step was to import our modules that we would need. ArcPy and the OS module were the main ones. We initially had the time module as well, but ended up taking that out because the script seemed to work fine without putting a delay timer on it, and it was faster that way. Then we checked out the licenses that we needed, mainly the spatial license for ArcPy, and then we set up our workspace. This folder on the desktop is where we put all of our data, and we set the overwrite output setting to true so that we didn't have to rename any files. It would just automatically overwrite them. Our next step was to set up directories for the input folder and the temporary folder where the intermediate files are stored. So as you can see, these are just folders here on the desktop as well. And this temp folder just gets overwritten each time the script loops through, so we don't have to rename anything. And this input folder is just where our main shapefiles, that Utah Watershed shapefile and the DEM, are stored. Our next step was to set up our variables. So we did that by putting them the directory for the temp folder plus a name for each file that would be created during the geoprocessing functions. As you can see, these three variables right here are taken from the user interface in ArcMap using the getParameterAsText function, so that the HUC shapefile and the DEM and then the PDF save location can be specified by the user. And by doing that, we make this tool more flexible, and people can do a different state or use a different DEM if they want to. Our next step was to set up this rows variable, which reads the rows of the HUC shapefile so that we can loop through them. So we just used that using the search cursor function of ArcPy, and now we know our rows function contains that each row of that shapefile. Then we initialize a counter variable, I equal to 1, to keep track of how many times we've gone through the loop. Next, we checked to see if the final PDF file already exists. If it does, we remove it and create a new one. So as you can see, we remove it here and then recreate it right here, just so we're sure we start off with a fresh PDF each time we run this tool. And then we begin looping through each HUC in the shapefile using a for loop. So for each row in rows, we perform all of these geoprocessing functions. Right here we added a message. As you saw when Jeff demonstrated the tool, it says begin geoprocessing for HUC and then the value of I. So the user knows how many times the loop has run. And this variable here is for our SQL statement, our SQL query, to select each each row in the shapefile based on the name. So as you can see, these geoprocessing functions, we select select a HUC. Don't really need to go through this in too much detail. You're probably familiar with the geoprocessing functions. But we go ahead and delineate the watershed and the stream network and output that to the final output shapefiles. So next, we read our map layout file into the mxd variable. This was one of the challenges we had in this script, because originally we were declaring this variable up at the top of our script outside of the loop, and we found that the shapefile, which is changed every time, wasn't updating on our output maps. So we found that by including that inside the loop so that it rereads this file each time through, we got the updated shapefiles like we desired. And then our next step was to set the extent of our main map data frame to match the watersheds layer. So we did that by selecting that data frame here, selecting the watersheds layer, and setting the data frame extent to match the layer extent. And then we updated the text fields on our map layout to match the name of the current watershed and the page number. So as you can see here, this title is updated each time to match the name of the watershed, and the page number is updated according to how many times we've gone through the process. And finally, we exported that current page of Atlas to a PDF file. We added a little message for the user so they can see that that's what the program is currently doing. So like I said, we export the single page and then we appended that page to the master PDF file. We did a little refresh active view here so that the current view in ArcMap will update, and then we incremented our counter variable. So that is our main loop, and after that runs for each watershed, we just save and close the master PDF file. So it's a pretty simple script. It's just 120 lines, many of which are comments or just setting up variables, and it accomplished exactly what we wanted to for this project. Thank you for watching our video, and have a great day.